this where we're gonna go over spinning up the VM?
Oh, that's right. We're going to do that first. All right, give me a second here. Let's bring up the. Where is it? Got too many windows open now. Here, there it is. Okay, so we're going to go into the AWS Management Console. I think I'm probably going to be timed out here. No, it's still signed in. All right, so I'm in the AWS console. For you guys, it doesn't matter what region you're in. So in fact, let's illustrate that point. We'll go to Oregon. And no, we're not going to go to Oregon. Actually, let's see if this works. We're going to EC2 in Oregon, and I'm going to do a search. I'm going to try this without the AMI ID. I'm just going to go to instances, and I'm going to say launch instance. And I'm going to search for CI/CD golden image. There we go. Oh, wait a minute. I was hoping for community AMIs, but I saw the AMI ID popped up. Let's try that one. So if this works, I'll drop this in the chat window. No? That's weird. I'm pretty sure that's the AMI ID. So, all right, my live radio demo didn't work out. Let me jump back over to Northern California and make sure I'm looking at the right ID. If I look in my AMIs, there's the CI/CD golden image. And that was the AMI ID, right? Oops. Guess I didn't copy it. This is our AMI ID right here for the one that we want. I'm going to copy that. I'm pretty sure that's the same ID. So I'm going to copy that, and I'm going to go back to Oregon just to make sure. Once I verify that I'm looking for the right thing. Yeah. That's weird. So I wonder if you have to be in the same region. I thought you didn't have to be in the same region to do an AMI search like that. Anyway, I'm going to drop the AMI ID in the chat window for you guys in the Zoom meeting here. That's the AMI ID, and it appears that I need to be in the same region. I didn't think that was necessary. But now if I search for that AMI ID, I should get one community AMI. Yeah, so you got to be in the right region. That sucks. So this public Amazon machine image is stored in Northern California. So from the top, what you'll need to do is go into AWS and whatever landing page you end on here, what we're looking for is EC2. So we could go all services, and this would be the all services list. We're looking for EC2 right here, top of the compute list. So we're going to select EC2, and then up here in the upper right-hand corner, I'm going to choose launch instances. And then in the search box here, I'm going to drop that AMI ID. And then when I do a search, when I press enter, I should get one result in community AMIs. Again, you need to be in Northern California to use this AMI ID. But once I select that community AMI ID, it verifies that is my CI/CD golden image. It has Visual Studio 2019, IntelliJ, Jenkins, and Maven on it, and we're going to select that one. You can use whatever size machine that you want. What we've been using in the demos here is a T2 extra large. So I'm going to go ahead and use that again. And I'm not going to bother setting tags for this one because assuming you're doing this in your own account, you're probably only going to have one or two of these servers up and running. So the tagging and naming isn't that big a deal. So I'm just going to do review and launch. And I don't believe there's anything else that I have to change for this to work. So at this point, I can just do launch. I'm going to tell it that I don't need a key pair. I'm going to proceed without a key pair because I acknowledge that I know the username and password for this instance. The username is administrator and the password is just M300, capital J, capital M. All right, so now our instance is launching, and from there, all we need to do is launch remote desktop. And with remote desktop, once our instance is launched, if we jump over here to our filtered list of instances, we can see that the public IP address for this instance, once it comes up, because right now it's still initializing, but once it comes up, we'll take this public IP address from here, and we will drop that into remote desktop here and hit connect. And once it comes up, we'll just log in with administrator with the password just M300, and then we can do all the demos and labs and exercises that we did here in class. All right, so that's how you get the machine up and running after class, because I'm going to kill them all off in about an hour and a half here. So the 20 or 20 some odd servers that we have running, if I forget and leave them running for a week or two, that'll cost us about $1,500. So I will be sure to promptly delete those right after class here. In fact, I'm going to delete this one right now because I didn't tag it or label it with anything, so I will very likely forget what that is and leave it running. So I'm going to terminate this instance, which you should also remember to do when you're done doing your labs. Actually, before I terminate, what you're going to want to do, if you want to keep using this thing, but you don't want to pay for it, when you're done working with it, you just stop it. If you stop it, it'll keep the server at its current state, whatever change that you made to it. It'll still be there. It'll be in your account, but you won't be paying for the compute time, right? And it's the compute time that costs you $1,400 if you leave it up. Excuse me, if you leave it up and running too long. Now, that time that I had a $1,400 charge, I think I had 25, almost 30 servers running for 2 weeks. So one server is probably not going to be that much. I think that one server will probably cost you like $5 a day or something like that. So not a huge deal, but if you're not using it for months at a time, it's a huge waste of money. So that's your Starbucks coffee every morning you're wasting by leaving that server running. So if you just stop it, it'll be there, but then you can come back and start it up and continue paying for it, but only while you're using it. So if you're going to step away for more than a few hours, definitely stop that thing and then start it back up when you're ready to use it. All right. So that thing is stopped, but I don't want it stopped because I'm never going to use it again. So I'm going to terminate it because, again, a week or two from now, I'll be like, what is this server? I don't know who made that, so I'm just going to leave it there. And then it's just there hanging out for the next 3 years. So I terminated it, which means it's going to delete it from my list. All right. So now what we are going to do is jump into this continuous integration stuff, because we want to make sure that on every compile of our code, or rather on every commit of our code to version control, we want to make sure that we get a proper compile and test run. All right. So every time we commit to version control with our continuous integration trigger, it will automatically fire off a build or compile, and then after that, it will continue on with a run of all of our tests. So we want this to happen at a minimum every 4 hours, right? Or I guess at a minimum, at least once per day. All right. So if we set our delivery team tasks at 2 to 4 hour increments, so we don't document, or rather we don't plan anything less than 2 hours, and anything more than 4 hours, we break into multiple tasks. That would mean that every time we finish a task and commit it to version control, we get feedback in the form of build results and test results. Now, depending on what type of automation tool you're using to do this continuous integration, some of these steps may not be necessary. Like this one, before check-in, run the build. Actually, this one's good. Before the check-in, run the build and tests and make sure they pass locally, right? What happens when you do the commit and the build trigger fires off is you get documented. What I mean by that is if you're getting bonuses or you're getting rewards for the least number of bugs introduced, you definitely want to make sure that you check privately and locally on your own system to make sure that you have no bugs before you try to commit it to version control, where you will be documented and punished for your bad behavior. Right? So we want to make sure we run locally first and make sure everything's passing. Preferably, we want to do a get latest version or a pull from the remote repository to make sure that what's in the repository merges well with what we're about to put in there. Because even if it passes on our local machine, once it merges or integrates with what's in the remote repository, it might not pass then. And then you will still be punished for your bad behavior, even though it was somebody else that changed the code while you had it checked out. All right. So this next step number 2, in Azure DevOps, we don't need to do this because it automatically locks the repo while it's doing the commit. Well, technically it doesn't lock it, but that's the easiest way to look at it. It really what it does, it puts our commit into a shelf, and then it runs the tests from the shelf. And if the build and the test don't pass, it just removes it. So there's no need to lock the primary repository because we're not putting something in, testing it, and taking it out. We're basically putting it over here in the lobby. And if it passes all the tests, then we let it go from the lobby to the hotel room. But anyway, we can skip that step in Azure DevOps. Then we check in. Now, we don't necessarily need to go to a different machine dedicated as the integration machine, because that's what's going to happen automatically for us in the background using Azure DevOps. But the idea here is to make sure that it works someplace other than just on the developer's machine. Right? So once we are done checking in and we get the results back as to what happened with our continuous integration build and test run, then we can continue on. Again, in Azure DevOps, we don't have to tell people they can update again because that's handled automatically by the system. And we don't have to go to a different machine to see if the latest code works because it's going to run on the integration server in Azure DevOps. So let's take a look at how that happens. All right. So we have to have a code repository first. And then in order for this to really make sense, so we get feedback early and often, we commit often, which is why we set those delivery team tasks to 2 to 4 hour increments. So that means at least once a day, hopefully twice or more per day, each team member is committing something to version control. That commit will trigger an automated build. If the automated build succeeds, then that will trigger an automated testing of the build, so an automated test run. And all the tests that were included in that commit will be executed automatically, assuming that Azure DevOps understands what kind of tests those are and you have the right NuGet packages loaded. Now, again, because this is going to happen every 2 to 4 hours for each member of our team, if it happens twice per day for each of our 2 pizza-sized team members, that means with our 10-person team, we're going to get 20 builds per day. Right? I don't think we talked about the 10 plus deploys per day goal, but we'll talk about that after we do this continuous integration thing. 10 deploys per day should be our goal at a minimum, not because the user needs 10 deploys per day, but because if you can deploy 10 times per day, that means your deployment takes on average less than 45 minutes, right? Because in an 8-hour workday, we have basically with 10 deploys, we have to do them about every 45 minutes to get all 10 of them in by the end of the workday, right? So if we set a goal to 10 plus deploys per day, that means we have to get everything automated to such a point that we can do a deployment every 45 minutes without fail. Now, the reality is it has to take significantly less than 45 minutes because that basically means you're deploying constantly all day for 8 hours straight. So hopefully our deploy, our build, and our test run take significantly less than 45 minutes if we're trying to achieve 10 deploys per day. So our deploy should really be, our deploy and our test run and our build should really be so fast that it takes less than a minute or two. All right. That way, every time we deploy, we go to the break room, grab a cold Mountain Dew and a cold slice of pizza, and come back to our desk. And by the time we get back to our desk, we should have an email or notification that says either we passed our tests, yay, or we failed our test and a bug has been created and assigned to us. No reward for you. right? Whatever the case, it's got to be fast. The results being visible to everyone, that's usually in a dashboard or some tool that allows those test results to be visible, which is why I told you guys earlier I'm not really a fan of fit and fitness, because there's no easy and automated way to view those test results. Last piece here is we want to use a neutral environment, not the developer's environment where everything is no security and they have godlike permissions on their machine. That's why developers wear this shirt sometimes. It works on my machine. I don't know what the problem is. Right? We want to make sure that it works everywhere. This is why there's these couple of references to test it in a neutral environment, go to a different machine. There's all these references to doing it someplace other than the development machine. But if we've got continuous integration set up properly, most likely the build is happening and the tests are happening on some machine other than the machine that the developer did the work on. All right. So the flow here is we have a change that's detected in source control. This is for you visual learners. I got a nice little flow chart for you. The change detected in the source control system, or rather the change is added to the source control or version control system, and that change is then detected by the continuous integration server. In this case, Azure DevOps. If we were doing Java and open source, we'd be using Jenkins for this. But once that change is detected, the system says, hey, something new is here. Let's see if it compiles. It runs the build. If the build succeeds, awesome. We move on to testing. If the build fails, we can configure Azure DevOps so that it automatically creates a bug and assigns the bug to whoever just checked in this bad code. Now, you remember yesterday we talked about, what did we talk about yesterday? We talked about vendor lock-in, that's right, and how vendor lock-in is an anti-pattern unless you're talking about the delivery pipeline. And the reason that I say that is because if we use that open source stack that I talked about yesterday, where we're running maybe Jira for the work item tracking, running Jenkins and Git for version control and automation, there's no out-of-the-box connection back to Jira from Jenkins or Git for that matter. So if we commit something to version control into Git and Git fires off a build trigger in Jenkins, and Jenkins goes back and pulls the files out of Git and compiles them and it finds a bug, Jenkins doesn't have any connection to Jira, so it can't automatically create a bug and assign it to you. Now, I'm not saying that it can't be done. It's just not as easy as what I'm going to show you right now, right? So in order to do that in the Jenkins, Git, and Jira combination, there's plugins that you have to actually buy, I think. There used to be a free plugin that would connect all those things together, but somebody figured out that they could make more beans if they sold the plugin. And so they bought whatever company was doing that, and then they stopped giving it away for free, and now they sell it. Or at least last time I checked and was able to find it, they were selling it. The last time I checked, I wasn't able to find it. So I don't know where it is now, if it's been renamed or whatever the case may be, but I'm pretty sure there's still a way that you can make what I'm going to show you happen in the Jira, Git, and Jenkins combination. It's just not easy, and it's not a checkbox out of the box. There's some plugins and some configuration that you'll have to do. Anywho, once we get that automated build and test, again, in Azure DevOps, if either one of those things fails, it'll create a bug and assign it to you. And it'll show your manager and all of your colleagues. So no reward for you. Okay? So that's why we make sure it runs locally and everything works. We pull down the latest version and make sure it integrates well and it still works before we commit it to version control, where that bug will be documented and shared with everyone. Oops. And obviously the last piece there that I haphazardly skipped over, the last piece there is the results get published. Right? And that's why we want to make sure it's going to work before we try to do it publicly. Test it locally on your machine and then publish it remotely, so you don't have to wear that t-shirt. All right. So let's go jump into our virtual machines and we'll take a look at this concept of continuous integration inside of Azure DevOps. So in Azure DevOps, I've got a project the same project that we created earlier in the earlier lab. And in this project, we are going to go to well, first let's take a peek in the repos menu. We see that our repo has nothing in it. So I have not committed anything to version control just yet. So we're going to go to the pipelines menu. And in pipelines, we are going to create our first pipeline, a build pipeline. So we're in pipelines here. I'm going to click on Create Pipeline. Now, we have created an ASP.NET web application, and we told it to store the ASP.NET web application artifacts in Team Foundation version control. If you guys recall from yesterday, I said we wanted to switch from Git to Team Foundation version control because Azure DevOps will let us do some nifty things, some extra things, if we use Team Foundation version control over Git. Now, these things, again, can be done with Git. It just requires a little more overhead and a little more work to do for the developer or whoever's configuring this pipeline. Now, this is a carryover because that last screen that we just looked at is relatively new. That came out about maybe 5 or 6 updates ago. But this piece here, selecting a source, that's the same question that we just answered on the previous slide or previous page. It just had prettier graphics. They were in color. Remember, the Team Foundation version control logo was purple. But you can see that's already selected here. They just haven't gotten around to removing it from this window. What we're doing here is specifying the workspace mapping. So it's basically going to map the server path for service reservations AV to the default local directory. Now, I could change it to some other directory if I want, but I'm going to let it just use the default path. Excuse me. I'm going to hit continue here. And now it's asking me what type of application are we building on this build pipeline. And because we chose to build an ASP.NET web application, I'm going to choose ASP.NET, build and test an ASP.NET web application. I'm going to apply that to my pipeline. And then I get my pipeline configuration here. Now, there's not much that we have to change here, but because we might want to look at code coverage in our test results, I'm going to come down here to test assemblies. I'm going to select that. And over on the right, I'm going to scroll down until I see enable code coverage. Code coverage enabled, check. All right. And then there are 3 other things that I'm going to change. I'm going to change 2 things in the triggers menu. So I'm going to select triggers here. And the first thing I'm going to do is I'm going to enable continuous integration with one hand behind my back. You ready? Done. Thank you. This is the difference between vendor lock-in and choosing the best-in-class tool for every step on your delivery pipeline. Now, again, I'm supposed to tell you that vendor lock-in is bad, but that's just organization-wide, in my humble opinion. Don't stick with one vendor for everything that you do in IT and organization-wide, because that's a disaster waiting to happen. But when we're talking about the delivery pipeline, there's so many things that we need to integrate, where we want to pass feedback forward and backwards, that it's kind of better to just stick with one vendor so everything's already integrated. Now, again, you can make this stuff happen with the open source stack. It's just not going to be a checkbox. You're probably going to spend several days buying plugins, configuring plugins, writing code to script everything together to make it work. Then it's going to probably be a more brittle solution than what we have here with just a checkbox. Now, the thing that caused us to switch to Team Foundation version control is this thing called gated check-in. And the reason that we can do gated check-ins, again, with one hand tied behind our back, is because we chose vendor lock-in, right? This is all Microsoft. So where we're setting the build pipeline is in the same tool or tool suite as where we're doing version control, right? And because of the way that Team Foundation version control works, that shelving stuff that I was talking about earlier, it can be done very easily because the version control system supports shelving or processing in kind of a private waiting room lobby type area. And then if that doesn't work out, we haven't actually put it into version control yet, so we don't have to do anything to take it back out. Because Git doesn't really support that in the same way, we would have to do a local continuous integration build and test. And if that failed, it's too late because we started the build and the test post-commit. So after the commit completed, then we started the build and test. So we would have to go and uncommit or try to remove those files. So that's why it's a little more complicated if you use Git. But here with Team Foundation version control, we can enable gated check-ins by just checking this checkbox, because what it was going to do anyway with continuous integration is it was going to build it on the shelf, and then once it was done building and testing, then commit it into the actual repository. So all gated check-ins are doing is saying if anything fails, just don't do that next step. But with Git, that step has already been done. So all we can do with Git is if the local build and test fails, it's already in the local repository, just don't push it to the remote repository, the repository that's shared with the rest of the team. So it's kind of the same end result, but there's a little more to setting it up. So those are the two things I'm going to change under triggers. The last thing I'm going to change is another result of this vendor lock-in that we chose. So in our continuous integration server, which would be Jenkins on the open source side, we can set an option here called create work item on failure, which basically means if the build fails or the test fails, we are going to create a bug by default, and we're going to assign it to the requester. Now you might be wondering who's the requester. Well, the requester is whoever requested this build. If you recall, our build is triggered by continuous integration. And as we just discussed, continuous integration is triggered by a commit to version control. So what we're saying is the requester is whoever tried to commit bad code to version control. So we're going to create a bug and assign it to that person so they get no bonus. No soup for you, 1 year. All right, so we can create several different types of elements. We could create a bug, we could create a feature, we could create a task, we could create a test case, we could create a user story, or we can create an issue. In my humble opinion, the only things that make sense here really are an issue or a bug. Now, I skipped over one. You can also create an epic, but I can't imagine why you'd want to create an epic unless
it was an epic failure.
So we're going to stick with bug. And that's all we're going to change here. So at this point, we can now save. We don't want to save in queue because there's nothing in our repository yet. So we're just going to save. We'll accept the default storage location. And now we have continuous integration. All right. Didn't write a single line of code. Didn't have to load any plugins. Didn't really have to know what I was doing, really. You could have figured that out with a quick Google search and scrolling through until you saw the checkbox to do a continuous integration. A lot more involved if you don't choose vendor lock-in. But now that we have that, let's jump back to Visual Studio. And remember, we reintroduced our logic error. So if I run my tests, I should get 3 failing tests again. My multi-push pop, or I guess 4 failing tests. My multi-push pop, and now it's back to doing a warning again. That's so weird. I don't understand why that one's a warning and the other 3 are failures. I don't get it. But whatever, it'll pass or whatever. It'll serve its purpose by not making it past the gate when we try to commit this code to version control. So I'm going to add solution to version control. What I did there is I right-clicked on the solution in the Solution Explorer, not the individual projects. Notice we've got 2 projects in our solution. So I'm going to right-click on the solution so I commit everything, or at least so I attempt to commit everything. Let's see here. So add solution to source control. Uh-oh. That's interesting. That's not what's supposed to happen at all. Let's try that one more time. Weird. I don't know why it didn't work the first time and it worked the second time, but whatever. Yay! So let's see here. We don't want stack utility complete. Rather, we want my service reservations AV. Here it is. Service reservations AV. And I could expand it. There's nothing there. I'm just going to accept that. My solution folder is going to be called service reservations, and it's going to put it in my service reservations AV repository inside the folder called service reservations. So I'm going to click OK. And I'm a little concerned now because that error popped up and then it fixed itself. And things that fix themselves usually break themselves again later. Okay. So we're not going to hold our breath that this is going to all go flawlessly. But if it does, I'll be very surprised. So you guys remember the other day when I said we want feedback early and often because sometimes you know something questionable went down. But if an error doesn't occur or if you don't get results from the test, you might not hear back from QA until 2 weeks from now. And then you're going to have no idea that it was this thing where the error came up and then the error disappeared that actually caused something quirky that caused it to fail a test 2 weeks later. So it's better to have those tests run immediately and get that immediate feedback. Because if something failed right now, I'd be like, I bet it has to do with that error that just displayed and then went away by itself. I need to look further into that area. 2 weeks from now, I'm not going to remember what I had for breakfast today, let alone what code that I wrote. So now that we've told it to add the solution to source control, you can see there's little plus signs here next to all of the files. What that means is this solution has been associated with version control. But if we go back to our version control, or rather go back to Azure DevOps and look in our repo, there's still nothing here. So it's associated, but it hasn't been added yet. So we've got to go back to Visual Studio and right click again. And this time we're going to choose check in. Now, I haven't forced this action, but we can very easily force the association of this check-in with a task or work item that's been assigned to us. Now, I didn't force it, but we're going to do it anyway. But imagine, if you will, that I'd changed a couple other configuration settings inside of my version control, and I told it to don't let anybody check anything in unless they add a comment, a check-in comment, and they also associate their check-in with a work item that's been assigned to them. Now, I forgot what that work item ID was, so I'm going to jump back over to Azure DevOps, and I'm going to go in here into boards. And let's see here. As a user, I need to stack stuff so I can move it around. I'm going to pop in there. Oh, actually, it looks like it was out there by itself. Let's go to backlog. I prefer the backlog view. So here you can see the user story. And the reason I prefer the backlog view is because as I'm looking at all the stories and epics and whatnot, you can see this little drop down, this little caret character that indicates that this particular user story does have subtasks defined. And when I expand that, you can see my implement stack task that we created, I think, this morning. So I'm going to go into that task and check its task ID. It's 2951. I'm going to jump back over to Visual Studio, and I'm going to add work item by ID. Now, if I was working on a project on a team and I was doing lots of tasks, I'd probably go and create a query that searched for things that were assigned to me automatically, so I wouldn't have to jump back and forth between Azure DevOps and Visual Studio. But in the interest of time and keeping this demo simple, I just jump back over to Azure DevOps, grab the ID 2951, and I'm just going to search by ID 2951, and that adds the implement stack task number 2951. Now, if I was simply checking in to trigger a build and get feedback, I might not want to mark this as resolved. I might want to just associate this check-in with that work item. That means it's not done yet, so it's going to stay in the same location on the Kanban board. It's in the doing column. Once I change it to resolve, then it's going to move it from the doing column into the closed column because I don't have approvals enabled. If I had approvals enabled, it would move into resolved and then into closed once it was approved. So we're going to try to check in now. Again, I didn't require check-in comments, nor did I require related work items to be associated. I just wanted to show you where that's done. So right now it's optional, but in a production environment, I'd want to require that no check-ins happen unless you tell me what work you were doing. That way, if something fails or something breaks later on, I can trace it back to the root cause. Antoine did this check-in, and he was checking in work where he was implementing the stack class, and after that, errors occurred. So something that Antoine did in the stack class is what caused the error. So now I don't have to look through the entire code base to figure out what Antoine was doing because Antoine associated his check-in with the work that he was doing that was assigned to him. So typically I want to force that operation in a production environment so nobody can check in without doing that association. Now here, because we chose gated check-ins, it's saying I can't check your code in until I run an automated build and test. So do you want to build your changes? If you say cancel, it just cancels your whole check-in. So in order to check in successfully, we need to build our changes. So here it says your check-in has been queued for validation. Click here to see the status of the validation build. So I'm going to click here, and over here in my code window, it's going to show me that the build has been queued. It's build request number 882. It's waited for 15 seconds in the queue, and then the build started 4 seconds ago with the build ID 2022 March 29th, and it's the first build of the day. If I click on this link, it's going to open Azure DevOps and the build monitor. Now here I can see that my build has been running for 20 seconds on agent job 1. And if I click on agent job 1, I can see the output for this job that's currently running. So it's using NuGet to load all the proper resources that my solution had in it on the integration server. So everything that I was running on my machine, since it worked on my machine, is now being installed on the integration server to make sure that it works on the integration server as well. So this is the NuGet package restore that's happening right now. It's downloading those things that we loaded into our project. The spec.run.runner and the spec.run.specflow are now being loaded on the integration server. And once that completes, then it'll move on to building our solution now that it has all the appropriate components. So we'll wait patiently for our build to run. And if our build is successful, which we fully expect it to be because it worked on our machine, then it'll move on to testing. And because we know we have this logic error and tests are failing, we should get a test failure and our code should be rejected from version control. So we should be just about done with our build. There we go. Build successful. Yay! And now on to the test run. Shouldn't take very long here because we're going to get a test failure pretty quick. But you can see if we get bored here, we can scroll through and look at the results. A total of 7 test files match the specified pattern. So those are all of our files that have the word test anywhere in the name. That's basically the requirement to get Azure DevOps to run your tests. All right, so starting test run, you can see all the tests that are running here. Once it stops moving around, we can scroll back up and see what happened. Now, my one beef, well, I was going to tell you what my one beef was, and it looks like they fixed it in the last update. I've been complaining about this for several years now, but it looks like they finally fixed it. That's funny. Yay! So, yeah, they totally fixed it. That's awesome. So, what used to happen here was very annoying to me, and I've been complaining about it for almost a decade, I think. But what used to happen here is down here at the bottom, where'd it go? Now I can't find that one. Down here at the bottom somewhere, it said test failed. And you can see there's a whole bunch of crap in here. There's a whole bunch of data in here that, oh, there it is. So this is what you used to get. This was red and everything else was white. So you remember what I've been saying the whole class, red bad, green good. It's universal standard worldwide. It's understood that red is bad and green is good, or red means stop, green means go. Well, this was the only red, and I think maybe this red was down here before as well. But if I wanted to see which test failed, I had to scroll all the way back through all this stuff, and I had to actually read it, or at least scan it all, looking for test failures, right? You can see here my past tests. Actually, no, this one failed too. So that's weird. That one's red. But up here, that's weird. Up here, we have red. So I'm not sure which ones they chose to make red, but at least they have red on the test failure. Before, you had to read everything to find where the test failed. But now it says In the multi-push pop in stack features, it failed because it was expecting item 2, but what it actually got was item 1. Same thing. All right, here we go. In multi-push pop 2, it failed because it was expecting item 1, but what it actually got was big ending. Multi-push pop 3 failed because it was expecting item 1 again, but got big ending. So I'm happy about this because I don't want to scan through and read everything. But when something fails, I don't want to just know that something failed. I want to know which test specifically failed so that I can go back and research that and solve whatever the root cause is. So I'm very happy that Microsoft has finally listened to my complaints and changed this white text that was very hard to find and scan through to red. So now, as you saw, I just quickly scrolled through, and once I saw red stuff, I stopped. You didn't used to be able to do that. You had to scroll slow enough where you could actually read and look for a test that failed to figure out what the results were. Now, you could also look at the test results in the commit report or the continuous integration gated check-in report. It shows there kind of, but I'd much rather see it where it's actually happening. So I'm very, very happy that Microsoft did that. Yay! That must have happened just in the last couple of weeks, because I swear, I taught this class like 3 weeks ago, and I'm pretty sure we looked through there, and that text was not read yet. So remember I told you that Microsoft is on a 3-week release cadence for Azure DevOps? Sometimes they break stuff, sometimes they fix stuff. This time it was a fix. Good job, Microsoft. All right, because it failed though, if we look in our repos folder, there's nothing in our repos folder still. So what we've got to do is go back and fix our stack class. And we're going to change from the logic error back to the fix. And then we're going to run all of our tests again. And we should see all of our tests are passing now. Yay! So now we should be able to run our check-in again. And as we run our check-in, same thing's going to happen. It's going to say, you can't check in until we confirm that your code compiles successfully and passes all the tests. So, okay, build my changes. Click here to see the status of my validation build. Uh-oh. Strange little errors occurring here. Not sure what that's all about, but it went away, fixed itself. I hate when that happens. But now we see the same build ID except for .2, because that means it's the second build of the day. Click on that. Check our results. Our agent job has begun. Now, we're not going to watch this agent job run this time because we have a pretty good idea what's going to happen here. So we'll go ahead and continue on with the regularly scheduled program already in progress, and we'll come back and check this out once the build is complete. By the way, who am I logged in as? I'm logged in the same way you guys are, as a DevOps student. So you could very well go to outlook.com. Oops. Outlook.com. And log in as DevOps student, and you'll get an email. Did it come in yet? No. So we'll get an email shortly here that, let's check another just in case. Oh, no, there it is. There it is. It's done already. Right? 3:30? How could it be done already? You're just looking at it. It wasn't done yet.
That was mine.
Oh, okay. We're all using the same email address, so he who builds first builds best, I guess. So yeah, mine isn't done yet, but once it gets done, it'll show up in the email. So because we're using the same account, it should show the project name, I think, but we can't call the projects all service reservations with no initials. But anywho, you get the idea there. So the workflow here is to do your check-in, approve the gated the validation build, go grab some water, get something to drink, get a snack, And within a minute or two, by the time you get back from getting your snack, you should see an email or a notification in Azure DevOps that indicates whether your build has succeeded or failed. And if your build succeeded, then you should have, my build still isn't done, but once your build succeeds, we can see my build succeeded, my test run's most likely going to succeed. I should then have in my repo some new files. So those of you that had a successful build already, go back and take a look in your repos folder. You should see your service reservations folder sitting in there now. So that means you have been successful.
Yay!
We're just going to assume that I'm going to be successful too. We'll come back over here. Now, in addition to the things that we've already automated, so at this point we've automated the build, we've automated the unit test run, and we've also automated the acceptance test run. At this point, what we also want to do is automate continuous inspection, right? That's that static analysis, checking our conformance to our naming conventions and our layering structure. So as we discussed before, we've got StyleCop, FXCop, we've got Sonar, SonarCube, and a few other tools out there that we can use for this purpose. We're not going to do a demo here in class. I've got a couple of screenshots to show you. And I suppose I can show you the SonarCube. I've already got that configured in Jenkins. But the tool that we used to use in Visual Studio was called Code Analysis. Not a very creative name for doing code analysis, but I suppose it's to the point. But Microsoft deprecated that about 9 months ago, maybe a year at this point. So we no longer have a built-in tool inside of Visual Studio and Azure DevOps to do static analysis, but we can still use StyleCop or FXCop or Sonar or whatever to do it third party after the fact. So that's the reason that we don't do the demo or the lab in here anymore, because the lab instructions use a tool that no longer exists. So what I will show you instead, this is an old screenshot from Sonar, and it gives you a nice little dashboard where you can see code smells, you can see violations, you can see code coverage, lines of code, and total coverage of those lines of code. So 67.8% coverage. That means about 33% of our code is not being tested or covered by our tests. And usually it's in the dark corners of our code where all the bugs live. All right. So what we just did was set up continuous integration. The next step on our delivery pipeline would then be to configure continuous delivery. Now, this gets a little confusing as we start to set this up in Azure DevOps, because the distinction between continuous delivery and continuous deployment gets blurred quite a bit here. Continuous delivery, if you remember, the definition is to be ready and able, most important words in the definition, to be ready and able to deploy to any supported platform at any time. And really what should be added to that is any supported version. Because if you have clients that are running an older version of your solution and they call the help desk with an issue, if you don't have that older version of the solution installed somewhere, then you cannot replicate their issue. So we need to be able to deploy at any time any supported version of the solution to any supported platform that our customers might be running, so we can replicate any issues that they happen to have. Now, in order to be able to do that successfully and consistently, we really need to adjust the way that we do design. That's some of those design pattern books that we talked about and the facade pattern that I showed you. We also need to be developing on trunk or close to it. If you haven't heard that term before, it's going along with that branching metaphor, right? So if we want to be happy and healthy, we need to avoid branching and hug a tree. Hug the trunk, right? Develop everything on trunk so that we don't have branching, so that we don't have to deal with merging and merge conflicts. And the best way to deal with developing on trunk with features that aren't quite complete, but we still need to commit to version control, is with something called a feature toggle, aka a feature flag. And basically what this allows us to do is to switch on and off things that aren't working, even though we need to commit and deploy right now. So normally we would do stuff on a branch, and those things that aren't finished yet, we just wouldn't merge that branch back into the trunk. But because we're developing right on the trunk and we need to support continuous delivery, if somebody says we need you to deploy right now, we just toggle off all the features that aren't ready for prime time now, and then we do our deploy. All right? But in order to do that deploy direct to production from development on trunk, and I wouldn't do that. I would deploy to a staging environment first. But remember, continuous deployment doesn't necessarily mean deployment directly to production. It just means the deployment is automated to some location where we can do some further testing. And maybe after an approval there, deployment is further automated to go out to production. But in any event, we need feature flags and extensive test automation so that we can make sure that we're not automatically and frequently deploying crap to our customers. And to that end, we need detailed feedback on any failures that occur so we can see what happened, what went wrong, and what we need to fix so that we can move on and be able to deploy out to production. Now, again, continuous delivery is just the precursor to continuous deployment. So continuous deployment is everything that we just discussed with continuous delivery plus a deployment to a production slot. Right? Not necessarily deployment to production, but deployment to a production slot. And if you haven't heard that phrase before, in Azure DevOps, we call basically identical servers slots. So a virtual machine that is spun up to be identical to our production server would be considered a slot in that same subnet. So we might have slot A and slot B. Excuse my chicken scratch I'm drawing with the mouse here. So slot B might be our actual production slot. And that might be, that's supposed to be a laptop. That might be where our users are actually accessing our system. So while our users are using our production version of the application on slot B, we are doing continuous deployment to slot A, right? And then we can have our focus group of users, our small select group of users that we have given access to our beta environment. They can run against slot A. Now, they'll notice some hiccups every now and then as we overwrite the old code that's there, but they can't be mad because they volunteered to be on the bleeding edge of technology, right? So if they have a hiccup every now and then, they don't like that, they can just switch back to the production version and out of the beta program. But once we're satisfied and our focus group of users are saying everything is awesome, yay! Then we swap the slots. Right? Slot A becomes slot B becomes slot A, and what the users used to be looking at over here, the production version, is now what was on slot A, that's now slot B, and they're looking at that as the production version. Now, the cool thing about this is what's known as a zero impact deploy or a non-destructive deploy. What that means is we're not doing a deploy that overwrites everything that's here. Right? Traditionally, what we would have had to do is delete everything that's on the production server and then redeploy the new versions of all of those files. And it's that redeploy, that copying of files where we can drop packets. A file can get corrupted. A file doesn't get copied for some reason. And now we've got a corrupted version of the solution out here in production, and our users start complaining that the service doesn't work. Right? So doing this slot deployment means that we can deploy to slot A, we can verify that slot A is working, and then we can swap the slots. And because all we're doing is redirecting DNS and we're not actually copying or deleting any files, nothing can break. Like worst case scenario, you redirect DNS to some incorrect location, which really can only happen if you're letting a human do it. They can fat finger it or they can make a mistake. But if this is an automated process, it's very unlikely that it's going to make a mistake swapping slots. So if something goes wrong, it's because the code that we deployed has a gap in the testing process and there's some logic error or some other issue going on. And the really cool thing about this process, as long as we swap it back before another deploy happens, what's over here now in slot A is just what used to be in slot B, the old production version. So if we swap the slots and users start complaining immediately, then all we do is swap the slots back. No need to do a restore from backup. No need to reinstall or redeploy the solution. The solution is still there and safe on slot A. Okay, so that's continuous deployment and slot deployment in a nutshell. So again, what we really want is one click to deploy them all. And I can't play my Lord of the Rings sound because I didn't fix that echo issue at lunchtime. But we want to be able to deploy as quickly and easily as possible with as few steps and as little human interaction as possible. So that means it's best if we have that single source of truth, that repository that stores everything for everybody, so that our deployments can be a single step, they can be repeatable, reliable, and consistent. The only way that we can get that 100% of the time is if no humans are involved. Humans make mistakes. Computers and algorithms do not make mistakes unless the human told them to make that mistake, right? The computer just does what we tell it to do, except for those old Pentiums that had the floating point error. So to do this continuous integration stuff that we've been talking about, there are several different options available. Jenkins, I mentioned. Team Foundation Server is not called that anymore. It's the tool that we've been using, Azure DevOps. I mentioned that if you're using Jira, Atlassian has an automation tool, a CI tool that we can use called Bamboo. There's also TeamCity. TeamCity's pretty popular out there. I've never really run into cruise control in production anywhere or Urban Code. But these are other solutions that are available out there that are open source or have minimal cost. The demo here is the one that I just did. I jumped ahead and did that early. So we created a new build pipeline. We enabled the continuous integration build trigger. We also enabled gated check-ins, which required us to use Team Foundation version control as our version control system, as opposed to using Git, which was the default. And then we enabled create work item on failure, so that if we tried to check in bad code, a bug would be created. And I just realized I never showed you guys the bug. If we go back over here and look at our boards, and we can see now that there was a bug that was created when I did that failed build. If we click on that bug, we can see that that bug is associated with the build that happened 18 minutes ago. And if we click on the link here, we can see that that build is build number 1. Right? And we can actually trace that all the way back to the commit, where we should be able to see, maybe not. Yeah, we should be able to trace that all the way back to the check-in that was associated with the work item that we were working on when we checked in. So that's why I like to associate the check-in with the work item that I was working on. So if something does go horribly wrong, if there is a test failure, I can trace it back and figure out what the work item was that this person was working on that caused the failure to occur. All right, now, there's no need to set up Jenkins because we just did all that stuff in Azure DevOps. But what I do want to do at this point is show you that continuous inspection stuff. Since Microsoft deprecated the code analysis piece in Visual Studio, I can't demo that for you in Visual Studio, but I can show you what it would look like if we were using Jenkins. And take a look at that. So if we open, or actually go back to our browser, I'm going to go to http://localhost:8080, I think. Yeah, and that brings me to Jenkins. For some reason, it's got the URL to SonarQube in here. I'm just going to change that to admin. The password is password, but the password that's already in there should work. All you have to do is change that URL that's in the username to admin, and you can log in. But the password, for future reference, just in case, is PA$W0RD. So here we've got a Maven build from 4 years ago. I'm not going to try to build this again, although if you're curious about what some of this stuff looks like in Java as compared to, that was weird. As compared to what we did in C#, this Maven build project has some of what we did with the echo tests in it. Now you can see here this little sonar icon here indicates that we have weird. Indicates that we have there you go. It indicates that we have a sonar scan that's run here. That's what these little sonar bars mean. If we didn't have Sonar Cube installed properly and referenced with this job, then we would just see a blue sphere if the test passed and red if it failed. So this is the exception to the rule of green good, red bad. In this case, blue good, red bad. But if we click on the sonar, it takes us to the URL that was there, localhost:9000, and the dashboard for our Maven build project. And you can see here, it's got 45 minutes worth of work. It's not 45 minutes worth of work, but it's guesstimating that the 5 code smells that we have will take us 45 minutes to fix. The reality is it would take us probably 5 minutes because they're really simple problems. But let's take a look. We didn't use a named package, so it's saying move it from the default package to a named package. That'll take 30 seconds depending on how many files you have. Add a private constructor to hide the implicit one. So we didn't build our own overloaded constructor. So it's saying, hey, don't just use the implicit constructor. You should build your own constructor so you can do whatever special stuff you need to do. And then two code smells are there's a complete the task associated with this to-do comment and another complete the task associated with this to-do comment. That's because I didn't delete the to-do comment. I did what I was supposed to do, but I didn't delete the comment. Therefore, it thinks there's still something for me to do. So all I really need to do is go in and delete that comment, and it'll be happy. Remove this method and declare a constant for this value. I don't remember what that one is. Oh, you remember I said it doesn't like it when we pass literal strings? So here I'm returning a literal string, hello world. And what it really wants me to do is create a variable or a constant, store hello world in that variable or constant, and then return the variable or constant. The same thing would happen if we give me a similar code smell if I tried to call a method and pass hello world as a literal string instead of putting it into a variable first and then passing it on. We're sorry, but it can be found. Oh, yeah, you shouldn't have to log in to access that file. If it's telling you to log in, something's wrong. In fact, try it again and just hit cancel on the login screen. If that doesn't work, I'll share a new link. That link may have expired. All right, anyway, moving right along. The idea here is that code smells, things that aren't necessarily syntax errors or compile errors or failed tests will be caught by the static analysis tool. Now, again, I don't want to spend a lot of time on this, but we've got a little extra time here. We got about another 45 minutes before somebody has a hard stop, and we don't have that many slides left. So let's take a quick peek in Eclipse. I'm going to show you that project that sonar scan was all about. If you open Eclipse and just launch with the defaults there, in that workspace, that default workspace is that Maven build project that we were just looking at in Jenkins. I'm just bringing you in here so you can see what the code looks like and what we were running and what we were testing. I'm going to close the welcome window. And in my package explorer, you can see the one thing that I have there. I'm going to skip this install. The one thing that I have there is my Maven build project. And in the source Java folder, there's the default package. That's what that one code smell was complaining about. Remove it from the default package and add it to a defined package. We've got our echo Java that has 2 methods, echo and say hello. And you can see this is what it was complaining about. I'm passing a literal string. It doesn't like that. In my tests, source test Java, default package, test echo. Here, I did things properly. I created a variable and I put the value hello worlds into the variable, and then I passed the variable as an argument to my method. Same thing here, variable, variable. took a value, stored it in a variable, passed the variable here and here. So there are no literal strings being passed, which is why the only code smell referred to the hello world where I'm returning the literal string. So that's why when we were writing the test yesterday and today, I had you guys create variables that weren't defined in the book. If you're looking at the instructions in the book, I had you just passing the literal strings. And I started doing that differently in the demo because sometimes we do this thing where we run the Sonar Cube scan and it gives you all these code smells for anywhere that you pass a literal string. So I decided from now on, I won't teach bad programming practices and I will always show you how to not get code smells. All right. Yeah, we're just about to the close of this. Actually, that is the close of this demo. One other thing I want to show you guys here, all the stuff that we just did in Visual Studio and Azure DevOps works very similar here in Eclipse. I just added a carriage return to my test file. I want to save all files, and you notice here in my unstaged changes, this is my Git staging window. It says, hey, there's a file here that has changes to it. Do you want to commit this file? If I go over to Visual Studio, same type of thing. My files, oh, they haven't been, wait, have they been checked in? Let's see here. We should be good here. Where's my refresh? I'm just going to do check-in again. It shouldn't require any additional work. My check-in was already successful. Yeah, I should just have, that's weird. Oh, it's still doing it. Never mind. There you go. Now that it's done, we see we have locks instead of plus signs next to all of my files. And if I go and edit a file, like my echo.cs, just like in Eclipse, once I edit it, it changes from a lock to a little check mark. That's the equivalent of what happened in Eclipse here. When I changed the file, it appeared in unstaged changes. So to get ready to check that in, I would drag it and drop it down here, and then I'd add a commit message, made a small change, and I'm going to commit. If we were doing what we did in Azure DevOps, we'd commit and push. But in order for gated check-ins to work, there'd be a couple more plugins I'd have to load and some more code I would have to write that says if the build and test fails, then cancel the push. But what I'm going to do instead is I'm going to do a commit, but I'm first going to get set up over here in Jenkins so that we can watch what happens. So continuous integration set up over here also. If we're looking at this Maven build job, you can see the last build was February 24th, 2018. But because I made a change and I'm about to commit that change, and we jump back over here, we see that there's a pending build. It's in the quiet period for 2 seconds, waiting just in case two people hit commit at the same time. It's going to do one build for both of those commits instead of doing one build right after the other. Now, assuming that I didn't fat finger something while I was messing around in the project, this test should still pass. I guess I should have fixed something. Let's fix where we are returning hello world and get rid of these to-dos. So get rid of that, and I'm going to do a string MSG equals, and then I'm going to put hello world up here. And MSG down here. And I'm going to delete the to-do from here. And that should get rid of a few of my code smells. Forgot my semicolon there. Oops. All right. Now, save all files. Drag my change down. Removed smells. Commit again. Jump back over here. We should get our little quiet period report. While we're waiting for that, let's take a quick peek over here. we still have the same 5 code smells with that last build that we just did. But this time, because I removed the to-dos and I fixed the literal string that was passing, 2 to-dos, 1 literal string, we should only have 2 issues left. The smells should be fix the constructor and don't use the default package. We go back, our build is done now. Now let's look at the sonar scan for that one. 3 code smells. What's left? Private constructor, immediately return this expression instead of assigning it to a temporary L. So it doesn't like my variable still. It wants me to use a constant. So can't win. It's saying that's good, but you still need to make it better. But you get the idea here. So these aren't errors per se. These are smells, right? Your code doesn't smell or doesn't fail. It just stinks. So write better code is all this is telling us. Our code will still work. It's still passable. The customer can still get their value, but it's not the best code we could have written. So that's the value of static analysis, that implied code review. All right, back over here. That was Jenkins and a Sonar cube that we were just looking at. So now that we have all this stuff in place, now what do? Now that we have all of our testing, we've got continuous integration, we've got continuous inspection, now it's safe to apply refactoring techniques without introducing new debt. So just FYI, I'm gonna run through here. There's about 5 slides here, and that's the end of the deck. So those of you that have a hard stop right now at 4 o'clock or 1 minute from now at 4 o'clock, you're gonna miss like 5 slides. And to be honest, there's nothing terribly exciting to say about these last few slides. Refactoring is easy and safe to do once you have tests in place. All that you're gonna miss, those of you that have to cut out now, is talking about a few of the different common refactoring methods. And I mean, there's 92 of them or 91 refactoring methods, and I'm only going to cover 3 anyway, so you're not going to miss much. Martin Fowler, the godfather of refactoring, says that refactoring is a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. So basically, we're changing the implementation, but not changing the inputs and the outputs. So the same way we have our TDD rhythm, we have the refactoring cycle where we identify a problem area, we add any needed tests to expose the problem, we choose a refactoring method, we apply the refactoring method, and then we rerun the test to verify that we didn't break anything by refactoring. And at the end of the day, the code should be left in a better state than when we started. It should be better, not worse. The whole reason we're refactoring something that already works is to try to make it better, faster, or cheaper as far as resources are concerned. So here's Martin Fowler's catalog of refactorings. As I mentioned, there are 91 refactoring methods, refactoring techniques, but very similar to the rules of normalization. By the way, I don't know if you left yet. I haven't checked the count. But for those of you that are leaving or have to leave before I get to the end, make sure you check your email for the certificate of completion. You should get actually a link with a link to the evaluation. They keep changing how they do this, so don't quote me. They used to do it so that you didn't get the certificate of completion until you filled out the evaluation and submitted it. And then once that got processed, it would automatically kick off the email that sent you the certificate of completion. But I think last couple sessions ago, somebody told me that they got the link to the certificate of completion in the same email that they got the link to the evaluation. So one way or the other, fill out the evaluation and get your certificate of completion, or you already have your certificate of completion and fill out the evaluation anyway, because that's how we collect feedback to determine what needs to be changed, fixed, updated, or if my annoying sounds really got on your nerves. All right, so anyway, now that that's out of the way, continuing right along here, the refactoring catalog here is very similar to the rules of normalization for database developers. People talk about the 5 rules of normalization or the 5 normal forms, but really only practice the first 3, and they think that that's all there are. But there are actually over 2,400 rules of normalization. But the reality is they're all really just nitpicky variations of the first 3. So as long as you're focusing on the first 3 rules of normalization, you're winning. The same is pretty much true here. Out of these 91 different refactoring techniques, I use maybe 5, right? Realistically, probably more like 3 on a regular basis. We saw extract method and generate method. So extract method is when you have code that's duplicated in multiple places. You highlight that code, right click and say extract method. And it asks you for a name of the method. You give the method a name, and then it would replace the code that you highlighted with the call to that method, and then move that code into a method and give it the name that you chose. Then you just take that method name and go around and replace all that duplicate code with the call to the method. That way, if you need to make a change, you make it in one location and it's replicated to all the places where you made the call to that method. Extract class I also use. I think rename is in here somewhere. I use rename. Obviously, you saw me use rename a couple of times. Anyway, I'm not going to go through the entire list here. You get the idea. There's lots of rules of normalization, and probably 3 or 4 that you'll use on a regular basis, and others that you'll use on much more rare occasions where you may have to do a quick Google search to see how it works. But the ones that I use most frequently are the ones that are usually built into a integrated development environment that I'm using. You saw the rename refactoring method is right in the context menu, as is the extract method and generate method. So this is what extract method looks like. And one of the advantages to extract method is that we don't have to include descriptive comments to describe what this cryptic code is doing. In this case, we have a comment that says we're printing details here, because that's what system.out.println name plus the name variable does. System.out.println amount plus the get outstanding function results. That's what it means to print details. So instead of having to put this comment in and having these 2 lines of code, we can extract method and give the method the same name as the comment, because the comment is describing our intent. The same way the comment describes our intent, the function name can describe our intent. All right? So now we don't have to have a comment. We just say print details, pass it get outstanding, and then we have a function that does the same 2 lines of code that we were doing in line here before. All right. So that's the value of extract method. We have another one here, replace magic number with symbolic constant. That's a refactoring method. There's not necessarily a tool built into the IDE to do that for you. But basically what we're doing is saying, we don't know what the hell 9.81 means. What is that anyway? So we'd have to put a comment in here to describe what 9.81 is, or we put it into a constant here, static final double gravitational constant equals the value 9.81. Now we say return mass times gravitational constant times height. And it makes much more sense because we've described our intent by using the name of the constant as opposed to a comment. All right, that, my friends, as they say, is that. So from here on out, one thing that I like to have you guys do at the end of class, I'm not going to make you share it with class or anything, but you can feel free to share your top things if you like. But consider the things that we discussed in class that might be helpful or useful to your organization. And what I really like for you guys to do is consider what concepts or practices, patterns and practices that we discussed in class are things that you could implement in a relatively painless manner immediately. Right? So what could you start doing immediately that would add value to your team? What things might you want to adopt next week or next month, because maybe there's a little political overhead that you have to deal with, or maybe some infrastructure elements that need to be spun up. But there are some things I think we discussed in class here, like writing your acceptance criteria in Gherkin format, that you could implement almost immediately without too much overhead or research spikes or what have you. So I'm going to give you guys 5 minutes to consider that, maybe flip back through the book and write down a couple of short-term, mid-term, and long-term goals. Again, that's not for me, that's for you, the takeaway for class. But if you want to share those, you're more than welcome to turn your microphone on and share your top picks. But I just want to make sure that before you walk away from class, before I pronounce it beer o'clock, and all this information drains out of one ear, that you jot down some short-term goals to keep it in your short-term memory. So when you get back to the office tomorrow, you can start implementing some of these things that you find valuable. All right. Beyond that, in this 5 minutes, also take a moment to check your junk mail folder and see if you got that email with your certificate of completion and the link to the evaluation. And if you didn't get that, I'll send an email off to my contact back at the home office to make sure you guys get a copy of those emails. So I'm going to set a timer for 5 minutes, check your email, think of some short-term, midterm, and long-term goals, and then we'll do our course retrospective 5 minutes from now. And for those of you watching on the live stream, that concludes my extended demo and a sneak peek at what happens in the Certified Scrum Developer workshop. You got just a tidbit of that. You got the tail end of a demo, and then our continuous integration demo. If you'd like to see more of that, subscribe to the channel and hit me up in the comments. Let me know what you'd like to see more of, and stay tuned for the next live demo. Thanks for watching, guys.